Hi, my name is Shula Sarkar. I work as a senior research scientist in the IPUMS project. IPUMS is housed in the University of Minnesota. My job in the project is mostly taking care of the geography and the GIS part of the data sets. So all the census files have a location code in them. So I help in creating GIS maps that match the census data so that your results can be visualized. We will go through most of this in this talk. So I broke out my outline into four big sections. The first one is a tiny section about why care, why use GIS and maps. The second section is a technical hand-like section on how you would take your data and make maps from that. The third sections are what are some of the practical considerations that you need to keep in mind while you are making the maps from the data. And then the final section is displaying some of the GIS data that you produced and what you can do with it, like what are your options. So we will go through matching your codes and labels and creating maps, where you would get the maps from, some of the software that you could use, and some of the issues that you need to keep in mind. At the end of my talk, we will also have a demo that has been recorded by my colleague Quinn Hyman. So he will show the demonstration in ArcGIS Pro, and hopefully it will give you some ideas as to how you could make GIS files from the data that you have. So my first section is, why would you use GIS and maps? Here is a prime example of why you want to use GIS files. This map has been produced with data from IPUMS National Historical GIS project. They have four distinct colors here: blue, green, purple, and the orangish brown. And each of these colors go from a lighter to a darker color. So the darkest shade of brown here mean these neighborhoods are mostly occupied by Asian people. And the lighter brown means it's a mixed. The predominant population is Asian, but you have mixed races staying there. So if you step back and look at the map, you will see that there are lots of darker colors in different parts of Los Angeles. And this means that separate races, like the whites, are staying together in this part. The black populations are staying congregated in this part, the Hispanic in this part of the city, and the Asians in this part of the city of Los Angeles. So it's a powerful map which shows you the prevalence of racial segregation at very, very low levels of geography in the city of Los Angeles. The next two maps are examples of disaggregating to lower levels of geography. This uses IPUMS international data that you have been learning about for quite some time now. So this is showing aging in Latin America. So this map shows percentage of seniors who are age 60 and above in the Latin American countries. Note that we don't have censuses from every country in every decade, which is why some countries are grayed out in every census. And darker the color, more the concentration of seniors age 60 and above in that area. So here we look at the second administrative level of geography, like municipios in most of these Latin American countries. So this shows a change from 1980 to 1990, and then again in 2000 and 2010. So you can see how the population changes. So aging, the influence of aging as we go from the 1980s to the 2010s. So these two maps demonstrate as to why you would need a map. It is more needed to visualize your data, to tell a story with your data, and it is more uh, interesting to look at a map than to look at tables and tables full of data. So to make these maps, what are the GIS softwares that are available? We in IPUMS, we use the ESRI, uh, ESRI, as people call suite of software. We use ArcGIS desktop version 10.8.1, and there is a newer version, the ArcGIS Pro 2.7. Note that these are paid versions. They are very, very powerful, um, but they do cost a lot of money. Um, we listed some open source softwares. The QGIS version 3 is kind of the best one that can be compared to the commercial softwares. It also has some 3D capabilities. QGIS also has a version 2, which is Quantum GIS, and you can automate map production. You can process geospatial data and generate some maps too. The GRASS GIS, that's the Geographic Resource Analysis Support System, that was developed by the US Army Corps of Engineers as a tool for land management and environmental planning. The GRASS GIS excels primarily as a free GIS software option for analysis, image processing, uh, digital terrain manipulation, and statistics. Then R, that has become very common these days as a statistical software package, and it also has some spatial and GIS capabilities with the addition of external packages. So on the left side is a part of Brazil. Um, and what I'm trying to demonstrate are the administrative boundaries from 1980 to 2010. So the red lines are the states. They are the primary level of geography in Brazil. And then from 1980, 90, 2000, and 2010, you see municipios. They are the second admin level of geography in Brazil. And as you can see that they are all overlaid one on top of the other. If they had similar boundaries from 1980 to 2010, you would have only seen one single color, which is the green color because 1980 is on top. But as they are overlaid as layers, you can see as the boundary changes, you can see the bottom layers. Um, so the fact that you can see all the colors in this map means that boundaries change through time. So creating this map takes advantage of the rapidly growing GIS technology. And usually, from what we have seen, there are fewer changes at the highest administrative level of geography. And as you go down in the municipio level, there are more changes at the lower levels of geography. The next section talks about how your census codes from the microdata can be linked to the map codes in the GIS files. So before we go into that, I wanted to tell you about the hierarchy of geographic data. So if you think about the Russian dolls, where you have a bigger doll and inside you have a doll which is slightly smaller, and then another one which is smaller, and you go on and on. You can think administrative boundaries are kind of like that. You have regions, then within the regions are departments, and within the departments are communes. We are talking about Senegal. That will be most of the examples in this presentation today. And that will also be the country that we are going to show as a demo. So in terms of Senegal, the black lines are the regions. They are the first administrative level of geography. The blue lines are the departments. They are the second administrative level of geography. And then you have communes, arrondissements, and villages. Towards the left side are the codes and the labels and the household frequency. Those are the numbers. They are given to us by the NSO. So we get microdata, which are lines and lines of data, of course. But if I do a tabulation on a geography variable, your left column is the code, the label, and the household frequency. That comes from the NSO. In the table on the right, we have the code and the label, and then we calculated the weighted population. Sometimes we calculate from the weights that the NSO gives us. If it's a flat 10% sample, it's easy to calculate, but more often than not, we have to get these codes from outside sources. So where do we get these codes from? From the published publications that the NSO publishes. So to the left, you have a screenshot of a page with the codes and like the male, female, sex tabulations for different areas in Senegal. And we take these numbers, you can see they are in boxes, and these are the same numbers to the right side. That was your table from the previous page, which got populated on the right side. So again, where are these coming from? They are coming from the census publication. For Senegal here, we use different books. So all these tables were there in different books. There was one main book, and then there were separate books for each region. There were many books, I can tell you. And we got the numbers from each of these books. So sometimes we do not get these books and publications. So we look out for alternate sources which can give us population figures. So here is another source, statoids.com. That is a website which is created by William Law. And he also lists the changes in boundaries at the first administrative level of geography. But the population figures here provide the population um, that the real population that goes in with that. Why we need real populations, we will come to that at a later point in the presentation, but we do need that along with the codes and the labels. So now we have our codes, our labels, our official populations. Now we need GIS files. Where do we get them from? The first and our preferred source are the National Statistical Offices. Some offices do give us their maps and boundaries, and those are very helpful because they usually will almost all the time they will match with the codes and the labels. Um, we have no issues with those. They also have local knowledge about the changes in boundaries. Sometimes we will download maps from elsewhere and we wouldn't know if a boundary is correct or not. The National Statistical Offices will almost always give us boundaries which are accurate. The second most trusted source is SALB, the second administrative level boundaries. They are vetted by the United Nations. They have the boundaries vetted, and we like them because their boundaries are also verified by the host country. They also have first and second administrative level boundaries, and they also have time from different time periods. So we have a slide later on that shows that, but they will have several maps, maybe one from the 80s, one from the 90s. So it tells you exactly where the boundaries are at different time periods. The GADM, the Global Administrative Boundaries database, they are one of the common sources. Their boundaries are very detailed. They go down to lower levels of geography, but the big problem with them is they only care about the most recent boundaries. They do not have a database of older boundaries. So they are very good with the current statistical files. The goal is the Global Administrative Unit layers. They are by the Dante project. We use them sometimes, but I think in between GADM, SALB, and National Statistical Offices, we have most of the times we are covered with our GIS files. There is another open source boundary from Revolutionary GIS. This person publishes really, really low level boundaries. We recently was notified of their site. We sometimes use their boundaries, but not all the time because they go to very, very tiny details which we might not need when we are doing census data. So here is a comparison for all the sources that were listed in the previous slide. The National Statistical Offices are a local coverage. Like I say, they are usually detailed. Sometimes we have to pay for that. And sometimes the NSO just gives it to us because they want us to release those boundaries. The other sources are free. Like I said, these two, the first two usually have historical boundaries and present day boundaries. The other sources are a snapshot in time, so we only get the newer boundaries. And the coverage is global for everything excepting the NSO, which only gives you data from one single country. So what we would prefer to get is a shapefile. That's a GIS file. So a shapefile usually will come in a set of 6 files, sometimes 8 files, but it has to come with a set of 3 files. So it's a set which comes. If you get a file known as something like shapefile.shp, that file is not going to work. A shapefile always has 3 files that it needs to function. The shape is the main file that stores the geometry of the feature, the polygons or the boundaries. The SHX is the index file for the shapefile, and the DBF is the database table that goes along with the shapefile, the attribute table. We'll talk a lot more about the attribute table in a later slide. Then the other files are a series of optional files, but they are all very important. The PRJ is the coordinate and projection system. Without a PRJ file, you wouldn't know if Morocco is actually situated in Morocco. If you have a file of Morocco without a PRJ file, it might as well land up in the middle of the Atlantic Ocean because it doesn't know where to place itself in the world. So a projection is needed to know where it is located in the world. The two XML files are the metadata associated with the shapefile. Where did the file come from? Who created it? What you need to know about the file? Essentially, data about the shapefile. The SBN and the SBX files are spatial index files that optimize some of the spatial queries. These two files makes up a shape index to speed up your spatial queries. So if your file does not come with a SBN or SBX, it is not the end of the world, but it would be great to have those. The CPG file is used to specify the code page for the character set that is used in your shapefile. If you don't have that file, then your default software will have a different character set as opposed to what you had in the original file. Bottom line, you need the top 3, which are in green. You should have a projection file and you should have the XML files. The others are, it is not really that disastrous if you don't have that, but it is good to have as many of these extension files as possible. So again, the shapefile is a package of files. One individual file is not like, it's a corrupt shapefile. Here is an example of GIS files that we got from the National Statistical Office of Tanzania. So they directed us to their website and we downloaded the levels of geography shapefiles from their website. So on the right-hand side is the file that we downloaded for the lowest level of geography that was that matched with our data. And then we have the attribute table and the codes that go along with the shapefile. So this slide tells us about, gives an example of the United Nations second administrative level boundary file download. So this is for the country of Senegal, like we are demonstrating. And here you can see the temporal validity for the different time periods. So the earliest file ranges from January of 2000 to 2002, and then their latest one is from 2008, and they last updated and checked this file on 2021. So we have a historical perspective and changes in boundaries represented in the different shape files that we could download from the UNSALB. So coming back to our GIS shapefiles, here is a GIS shapefile that we downloaded from UNSALB. We downloaded 45 units, which exactly matched with the microdata file that we had. The file looked exactly what we wanted and what matched our data set. Now, in IPUMS world, we always do a cross check. Like we download files from another source, if there is another source, of course, and cross check the two files together. Here is a file that was downloaded from GADM. Again, we downloaded 45 units. The red lines are the SALB units and the black lines are the GADM units. So as you can see, the boundaries are more or less same. The SALB file in this case is very generalized, like the lines are straight, whereas the GADM file, you have a more detailed file. So usually we would use a SALB file, but this was one of the cases where we decided to go with the GADM file because the file was more detailed in nature. We had the same number of units, so we just went with a file which we thought represented the boundaries in a better way. So this is the attribute table, the DBF file that I was talking about previously that came with the GADM shapefile. The two columns of interest are names and codes. So for this case, the Senegal 2013 example, our codes exactly matched the codes in the microdata. So it was very simple for us. All we had to do was to link the data with the map, and we had our map that was ready to use. But not every country has it that simple. So here is an example from China 1990. This is one of the older China files that we had, where we had a hard time matching up the codes and labels. So on the left side, this table shows us the labels and the codes from the China Administrative Level 1. We look at this in the census publications. Here are the two codes that we are looking at, the 44 and the 45 in a published source. And below it, you have the second administrative level. Remember the nesting that I talked about, where the smaller codes are nested within the larger codes. So here on the right-hand side, we have exactly that. So 44, the first two numbers are from the Guangdong province, and the 45, the first two numbers here, as soon as it changes into 45, are from the Guangxi province. And then the following codes are the second administrative level codes, which are nested inside. So one of the problems we had was the microdata did not come with a label for 4502 code, and we had to figure out what the label was. There were other issues too. So if we look at that, 4401 was Guangzhou city. And then we also had a Nanning city and a Nanning prefecture. And we weren't sure if that was correct or not, if both were uh, Nanning or if there was a mislabeling. But we had to look at the published figures to figure out that the Nanning P meant Nanning prefecture, and the Nanning city here corresponded to the Nanning city. Um, so the next one was Lijiao city, which was missing over here, but there was a Lijiao prefecture. So we labeled this code 4502 as Lijiao city. So to do that, this is the book we referred to, and for several countries in our database, and this happens specifically with the historical censuses, just like this was China 1990, we had to go back to the published figures and actually figure out what the codes were. And then once we have all the codes and the labels, then we can get the weighted frequencies um, along with the codes. So far, I have shown you where we always have a GIS file that matches with the code. But sometimes you don't have a GIS file. Like I showed you several sources, GADM, UNSALB, GAUL, but we didn't find a map that a GIS map that matches the data. And this again usually happens with the historical files. So what do we do then? We take the paper copy map, we georeference and align the JPEG image, and then we digitize. So it's plain and simple historical digitization. My colleague Quinn Hyman will be giving a demo after I am done talking, and he'll show you a brief example of how we georeference the JPEG image to the shapefile. But that's one way to do it. So to the left, we have an example from China where we show you an example of how we use a paper copy map. And to your right over here, we are again bringing in Senegal. But here we are showing Senegal level 4, like third and fourth level administrative level of geography. So they are teeny tiny units, and in case we have data that matches these maps, these are the kinds of maps we would use to digitize the boundaries. So here are some screenshots of digitizing and georeferencing. So this is from Venezuela, and we are doing one particular province in Venezuela. So if you look at it, we are just doing this little province here that we are going to georeference. So we take the map and reference it accordingly. And then here is a zoomed in version. Once the map is referenced, we draw the lines manually, digitize the lines, and get our map. So some practical considerations that need to be kept in mind when you are working on GIS. So one question that we always are asking is, do you want a bottom-up approach? Meaning, do you want to go from the most detailed map to the least detailed map, like admin 3 to admin level 2 to admin level 1? Or do you want to go from admin level 1 to admin level 2 to admin level 3? That's more your choice, I would say. In my personal opinion, and in the IPUMS world, we usually acquire the most detailed map, and then we merge boundaries and create a level 2. Again, we merge the boundaries and create a level 1. I think that's faster, but there is no hard and fast rule, and you can always go the other way around. Similarly, do you want to go from the latest sample to the oldest sample, or do you want to go from the oldest sample, like 1988, to 2013? The basic presumption is that as population increases, 1 unit will be split up into 2 units. So if you start with the most recent one, it is easier to merge units and create bigger units which go back through time. But again, there is no hard and fast rule for you to go from 2013 to 1988 in this case. You could definitely start from 1988, digitize lines, do 2002, digitize more lines, and get to 2013. So these are two ways that I'm just highlighting. Which brings me to the point is, do you want to merge polygons or do you want to split boundaries or polygons? So if you are going from the most detailed to the least detailed, then you are merging boundaries. You select all these polygons and then you merge. But if you are going the other way around, from more detailed to a less detailed to a more detailed, then you are going to create lines, in which case you are going to split this bigger polygon into several polygons. So here is a screenshot of merging boundaries. The first one, you have this line, you have 3 boundaries here. As you can see in the attribute table, you have 3 units. You use a merge function, it becomes 1 unit, which is like this. The same way for splitting, you have one giant boundary, you have a map which is used as a reference, you are drawing a line which is used to splitting this boundary. So you had one giant boundary which is selected, and once you are done with the split, you have 2 boundaries now. Again, my colleague Quinn Heinemann will be showing this at the end of the presentation, so maybe it will be a little more clear, but as someone who's preparing these GIS maps, it is for you to decide if you want to use a merge or a split. If you want to go like most recent to the oldest boundary, or if you want to go from the oldest boundary, meaning fewer lines, to creating more polygons. The other thing I wanted to highlight was the power of the attribute table. The attribute table is fairly powerful. It's like a database file. You can do joins, bring in outside data. You can find, query, SQL query. You can use Python. You can use expressions. There is a calculator function. So there is a whole slew of things you can do with the attribute table, and I just wanted to highlight that. The other thing that needs to be kept in mind is map topology. In terms of polygons, because we are talking about administrative boundaries, I'm going to talk about polygons. When you have 2 polygons which are like side by side, you should not have an overlap, you should not have a gap. Then that's an error in the map. Also, while you are drawing lines, there is something known as a cluster tolerance. So when you are, let's say, drawing this line from here to here, if your cluster tolerance is like 0.1 inches, then any line that you draw close to 0.1 inches will snap to the polygon and you will not have a hole. Otherwise, you are bound to have one of these gaps. So please make sure you understand what a cluster tolerance is and what you are doing, the editing that you're doing in ARC or whatever software you are using must be larger than the cluster tolerance. The other thing to note are international boundaries. If you download maps from several sources, it is imperative that the boundaries are not going to match. Like here, you have the GADM and the UNSALB map. And if you look at the boundaries, the borders, the international borders, they are not matching. Here is a river in one and river in another map, and they clearly don't match. So the point I'm trying to make is please be sure to document where you got your boundary from in the XML metadata that comes with the shapefile so that someone who's using the maps downstream knows where it came from, how they got it from, and how to work with it. One of the last things I'm going to cover is map confidentialization. With the GIS technology and the map that you have, map confidentialization is of paramount importance. So if there are units which are really, really tiny and small, you can merge it with the neighboring unit because it might expose some vulnerable population. So to your left, I assume that you are going to confidentialize every boundary where the population is below 30,000. I just chose an arbitrary figure. I know 30,000 is a high population and you really do not need to confidentialize population below 30,000, but I just had to choose a number. So, and everything in green, I'm assuming you don't want to confidentialize in this map. The other map is a map of Senegal based on the density of population. Lighter colors means low density, darker colors mean higher density. So here are some of the rules of confidentialization. I am saying population is greater than a particular threshold. For here, I'm choosing 30,000. The units should be contiguous, side by side, with a similar population density. You could use any other parameter. They could have similar language, similar food habits, similar terrain, whatever you choose. In this case, we chose population density. It should be within the parent unit, like all confidentialization in this unit should be contained within the darker black line. Like you cannot combine this unit with this unit because they are from different parents. And the units should be compact, like a nice compact shape, and not skinny, like not like a snake, like a long one. And the last point I highlighted is local knowledge and considerations. One reason why you might want to confidentialize by yourself is you have the best knowledge about your country than we do. IPUMS does this for you all the time, but we would love an input from you because you have the knowledge that IPUMS doesn't. So here is the same map zoomed in. And here is the same part with the density of population. So the two units, red arrows, I'm going to merge those two with the one on top because they have the similar density. Remember, I used population density as my parameter. Similarly here, I'm going to merge that unit over here, and I'm going to merge this with this and this with this. You might choose to merge this unit here because maybe they speak the same language, and that's the parameter you are using. This is what I would do if I were using population density as my parameter. The last section, I'm going to go through it quickly, is displaying the GIS information. So now you have all these maps that you created. What can you do with it? You can visualize your data. You can report on the sustainable development goals and indicators. You can disaggregate to very low levels of geography, look at changes over time, make policies, and create dashboards and report on indicators. With IPUMS data, or rather with census microdata, you can do a whole slew of goals and targets for the Sustainable Development Goals. We list some of these here. Here is a map which shows the percentage of children less than 5 years old and who have no access to piped water. This is the 2010 census round from Africa, and we show disaggregation at different scales. This is at the national level, this is at the first administrative level of geography, and this is at the second administrative level of geography. This is an example where we show the percentage of households with access to electricity in Cambodia. What I'm trying to portray in this map is not only are we showing the urban and rural population, but we are also bringing in satellite data from outside sources to show urban and built up areas in Cambodia. The next map shows how we analyze changes over time and show the percentage of households with access to electricity in Bangladesh and how it improved from the year 1991 to 2011. And this visualization was only possible because you had the maps to show it. You could show it with your data, but the maps are always a better thing to portray. Um, this map shows disaggregation at very, very low levels of geography. Here we are looking at proportion of urban population living in slums in Mexico 2000 and 2010, and we see how that changed from 2000 to the 2010 census round. Another example of policy implications. So again, we are looking at older population above 60 living in urban areas and in rural areas. And you can see the distribution in the rural areas are along the sides of the country, and you can see the distribution in the urban areas and how they are concentrated on the two main cities in the urban areas. The last two slides are showing indicators and dashboards. Here is the UNFPA COVID population vulnerability dashboard that uses some of the IPUMS boundaries and the boundary files and displays this data. And the final dashboard is for the world population dashboard showcasing the global population data, and that also uses IPUMS data and maps. Thank you for listening to me. I hope I was able to explain some of the GIS concepts and also convince you to produce your own GIS maps and, of course, pass it on to IPUMS. The next section is a small hands-on um, demonstration in ArcGIS Pro by my colleague, Quinn Hyman. Thank you.